Okay.
Nervous system. Nervous system, as we know, comprises of the neurons, which are structural and functional units of the nervous system, and the supporting cells. Neurons are structural and functional units of the nervous system, and there are some supporting cells known as the neuroglial cells. The nervous system has been divided into or classified into central nervous system, CNS, and peripheral nervous system, PNS. The central nervous system, this includes the brain and the spinal cord. Brain and spinal cord. And peripheral nervous system, this comprises the somatic nervous system and autonomic nervous system. The brain has been further classified into three groups, four brains. This is also known as prosencephalon. Midbrain, also known as mesencephalon. And hindbrain, known as rhombencephalon. Now, the prosencephalon has been further subdivided into two parts. The telencephalon and diencephalon. Rhombencephalon again has three parts. The pons, medulla oblongata, and cerebellum. In each of these parts, there are cavities known as ventricles. Or the telencephalon. Telencephalon is comprises of the cerebral hemispheres, and in each cerebral hemisphere there is a cavity known as lateral ventricle. The cavity present in the diencephalon is the third ventricle. The mesencephalon has a narrow cavity known as aqueduct of Sylvius or cerebral aqueduct, and the rhombencephalon has got a cavity known as the fourth ventricle. All these cavities are connected to each other, and finally these cavities are also connected to the central canal of the spinal cord. Now, before going to the details of the nervous system, you should know about the development of nervous system. Development of nervous system. For seeing the development, we should have a look on the trilaminar germ disc. child laminar germ disc having three layers, the ectoderm, endoderm and endoderm. This is the germ disc. Near the head end, there is the procaudal plate, and towards the tail end, there is primitive streak and primitive knot. Now, extending from the cranial end of primitive knot to caudal end of procaudal plate lies the notochord. This is notochord. Now, when we take section of this embryonic disc, like this, three layers are very clearly visible. The ectoderm on one side, the endoderm on the other, the notochord, it lies in the center. This is notochord, and on either side of this there is a mesoderm. This is intra-embryonic mesoderm. Now, the ectoderm overlying the notochordal process in this region. This modifies, becomes thickened and forms a plate known as the neural plate. This is neural plate. This lies dorsal to the notochord, and this also overlies the medial part of intra-embryonic mesoderm. The neural plate is ectodermal, also known as neuroectoderm, and most of the nervous system is ectodermal in origin except microglia, which is mesoderm. With the growth process, the neural plate grows and forms a fold. This is general ectoderm, general ectoderm. This is endoderm, the notochord, and the neural plate forms a fold. It becomes like this with the growth process. The edges are known as neural folds, neural folds, neural folds. And the depression in the center, the neural groove, neural groove. With further growth, the neural folds, the edges of the neural plates, they come closer and finally they fuse with each other. This can be shown like this. The ectoderm, the endoderm, the notochord, and the neural plate forming a tubular structure by fusion of the edges of the neural tube. This forms a tubular structure known as neural tube. Now the fusion of the neural tube starts from the middle, and this grows cranially and caudally. And and at the end, at the cranial end and the caudal end, hole is present, and that hole is known as neuropore, anterior neuropore and posterior neuropores. The anterior and posterior neuropores, they obliterate at 20 and 25 somites stage. Now, the neural tube, this gets detached from the surface ectoderm, and surface ectoderm is repaired. The surface ectoderm is repaired, the endoderm is there, the neural tube is there, this is the neural tube, and this part is the notochordal process. The neural tube lies dorsal to the notochord. Now, at the junction of the neural plate and the general ectoderm, the tissue differentiate and form neural crest. Cluster of cells present at the junction of neural plate and the general ectoderm. These clusters are known as neural crest. Neural crest. With the detachment of neural tube from the surface ectoderm, the neural crest, they also get detached and they come to lie dorsolateral to this region. Dorsolateral to the neural tube. Neural tube. The neural tube, this extends from the cranial end of the primitive knot to the caudal end of procaudal plate. Cranially, you will get the anterior neuropore. Caudally, the posterior neuropore, which later on obliterate. The tubular structure is lying ventral to the general ectoderm and dorsal to the notochord. And neural crest cells, they are situated dorsolateral to the neural tube. Now, the neural tube has longitudinal subdivisions. Its cranial part forms vesicle. Cranial part of the neural tube expands and forms 3 vesicles, like this. 3 vesicles. But its caudal part remains tubular. These 3 vesicles are the cranial moves, the prosencephalon, then the mesencephalon, and then the rhombencephalon. The prosencephalon further subdivides into telencephalon and diencephalon. Mesencephalon remains as such, and the rhombencephalon divides into myencephalon and metencephalon. The myencephalon forms the medulla, and metencephalon just develops into pons and cerebellum. The cavity inside, the cavity which is lying inside, they persist throughout life. In the region of the brain, they form various ventricles, and in the caudal part, which forms the spinal cord, it persists as the central canal. And these cavities, they communicate with each other, like this. They communicate with each other. the caudal-most tubular part which develops into spinal cord. Spinal cord. This is section of the spinal cord, a circular structure, transverse section of the spinal cord, the cavity inside it. With the growth of the tissue, proliferation of tissue occurs on the sides of the tube. Sides of the tube. It grows like this. The tissue starts growing in this direction and gradually it grows like this. The lateral parts, they become thick, and ventral and dorsal part, they remain thick. Now, a longitudinal sulcus appears in the internal surface of the thick lateral regions. Like this. This is the sulcus. Since it is transverse section, it appears like this. In longitudinal section, it is present longitudinally and is known as sulcus limitans. This is sulcus limitans. Sulcus limitans. This divides the lateral mass into two parts. The part lying ventrally is known as basal lamina. Basal lamina, and the part lying dorsally known as alar lamina. Ventral part, this part is basal lamina and this part is alar lamina. The thin portions lying dorsally and ventrally, they are known as roof plate. This part is roof plate and this is floor plate. Floor plate. This is roof plate and this part is floor plate. In this way, the tubular spinal cord is subdivided into different parts. The thickened lateral regions divide into alar lamina and basal lamina, and the thin portions dorsally the roof plate and ventrally the floor plate. This is the cavity, the central canal, and this notch which forms a sulcus longitudinally known as sulcus limitans. With further growth of the tissue lying laterally, the alar lamina on the two sides, they fuse with each other. The cavity, which was at the initial stage circular, changes its appearance. It later on becomes oval in shape, then diamond in shape, and finally with the fusion of the alar lamina, it becomes almost triangular in shape. The tissue is growing further. This is the tissue growing. This is one side of the tissue. Dorsally, the alar lamina, ventrally, the basal lamina. The alar lamina is sensory in function and basal lamina is motor in function. Now the proliferated tissue in the lateral walls, they differentiate into three layers. The peripheral most layer, this part. is known as marginal layer. Marginal. Marginal layer. Next to it is this part is the mental layer. This is the central canal. This part is the mental layer. Mental. And the innermost part, this region, the ependymon. Three layers. The peripheral zone, the marginal layer, deep to it is the mental layer, and then the ependymal layer all around the central canal. The marginal layer forms the white matter, the mental layer forms the grey matter, and the ependymal layer develops into the ependymon. Now coming to the grey matter portion. The basal lamina. Basal lamina differentiates into two functional columns. Ventral grey column and lateral grey column. Ventral grey column and lateral grey column. I've told you that the basal lamina is motor in function. The ventral grey column, also known as somatic efferent column. Somatic efferent. Somatic efferent. And neurons of this region supplies the muscles developing from the somas, like the muscles of the limbs, muscles of the trunk, and muscles of the neck. The lateral grey column, known as general visceral efferent column, also known as general visceral efferent, GVE. These are the neurons present in the lateral grey column, and they form the sympathetic part and sacral portion of the parasympathetic part of the spinal cord. This is related to autonomic system, sympathetic and sacral part of parasympathetic. The alar lamina lies dorsally. Alar lamina lies dorsally. This is sensory part, and this forms the posterior or dorsal grey column. Dorsal grey column. And this has two components. General visceral afferent. General visceral afferent. General visceral afferent. This carries sensation from the viscera and the blood vessels. And the other one is known as general somatic afferent. General somatic afferent brings sensation from the skin, joints and muscles. In this way, in the spinal cord, the gray columns are subdivided into 4 functional regions: the somatic efferent, general visceral efferent, general visceral afferent and general somatic afferent. These are known as the functional components, and all these functional components are present in all the spinal nerves. You know, there are 31 pairs of spinal nerves, and all the 31 pairs will contain all these 4 functional components. The basal lamina is motor in function. It extends cranially up to the midbrain, and they form the lower motor neurons. Basal lamina, this extends cranially up to the midbrain, and they form lower motor neuron. And the alar lamina, being sensory in function, this extends throughout the extent of the neural tube, and they form association neurons in which the central processes of the peripheral ganglia terminates. Sensory ganglia, they terminate. Now, we have seen the neural tube. We have also seen the neural crest. The neural tube has developed from the neural plate. The neural plate contains the precursor cells of the neurons and the glial elements. The precursors of the neurons are known as neuroblast, and the precursors of the glial cells, the glioblast. Neuroblast and glioblast. The neuroblast, they give rise to cells which form the nuclei present in the spinal cord, the brain stem, the cerebrum and the cerebellum. They also form the nuclei of the reticular formation, and they also form the cerebral and cerebellar cortex. The glioblast, they give rise to the glial elements specific to the nervous system. The neural crest cells. The neural crest cells, they give rise to the neurons of the peripheral sensory ganglia. The neurons of the peripheral sensory ganglia, this includes the neurons of dorsal root ganglia related to the spinal nerve, then the neurons of the cranial nerve, 5th, 7th, 8th, 9th and 10th. The sensory ganglia related to 5th, 7th, 9th, 10th and also the 8th. The neural tube is ectodermal. This gives rise to all the parts of the nervous system. The microglia, they are mesodermal in origin, and the neural crest cells, they also give rise to the neurons which lie outside central nervous system. When we can conclude it in this way, the neurons which are situated inside the central nervous system, they develop from the neural tube. And the neurons situated outside central nervous system, they develop from neural crest. This is all for today. Rest in the next.